This is Lab 1 for Principle of Physics 2, Charge Tapes by Jaime Clemente Tejada. The goal of this lab was to give charge to two pieces of tape, observe how the two pieces of tape interact, and then determine the charge from the interaction, and then to simulate the experiment in VPython. The findings were that the pieces of tape repelled one another, that the charge of the tape was 1.68 times 10 to the negative 8 coulombs, and both the pieces of tape were positively charged. There are two key concepts in order to understand this lab. First would be Newton's second law, which states that the net force is equal to change of momentum over change in time. With this, we could derive the updated position as well as updated velocity formulas, which would be using in order to calculate the net force of the two pieces of tape. And net force is important because the two pieces of tape will be in static equilibrium. Another very important concept would be electric force and Coulomb's law. The electric force equation allows us to calculate the amount of force exerted by two particles. As you can see, it is the Coulomb constant multiplied by the quotient of the two charges over the directional vector, or the distance between the two charges squared, all in the direction from the directional vector. We can see that the Coulomb constant is just simply a constant that's carried throughout, and as we can see, the magnitude of the electric force is not based upon the directional vector. There are four key assumptions made in this lab. First of all is that both tapes act as a point charge at the center of the tape, which pretty much means that we act as if the entire strip of tape, is one singular particle, which is located in the middle of where the actual piece of tape is. We also ignore air resistance, as one of the pieces of tape will be moving upwards. We also assume that both tapes have the same amount of charge all throughout the experiment, and then no other charges are affecting the tapes even when we are handling them. Now, as for the procedure and experiment, we have to first create two strips of U-tape. To create one strip of U-tape, you take two pieces of tape, you stack them on top of one another. For the top piece of tape, you bend one end into a U, and then you stack them on top of each other, and then you rub the two pieces of tape on top of one another, and then you rip it off. The actual ripping is what gives the charge to the piece of tape. You repeat this process to get the second piece of U-tape. You place one of the U-tapes suspended in the air in between two things to hold it upright, and then you bring the other piece of U-tape underneath, and then we can see in the actual experiment that this suspended piece of U-tape actually got repelled upwards. So the experiment that I collected, which is the number of atoms, which is 2.8 times 10 to the 9th. This is found by dividing the mass by atoms, in which case we get 2.8. And then we have the vertical distance moved. This was measured with a meter stick. And then we have the total mass. And then we have the number of electrons lost at 1.97 times 10 to the 14th power. Here we have some screenshots of the computational model modeled in VPython. On the left, you can see here the constants. And then towards the bottom, you can see how the gravitational force and the electric force were actually, how the vectors for those were calculated. And now for some discussions, results, and possible sources of error. Through the experiment, we found that both tapes were actually positively charged. Another important thing was, while the second piece of tape was suspended in the air, that we assumed that the forces were equal and that they were in static equilibrium when it was stationary. And some sources of error can include inaccurate measurements, since we took some of them with a ruler stick and we used our eyes. The pieces of tape were actually not parallel when we did the experiment, and then some rounding errors throughout calculations. Now for the discussion questions, what if the electrons had positive charge and protons had negative charge? Or what would change about the options you made with your tapes and other charged objects? The electric field direction would change. Instead of pointing outward, it would point inward. And the piece of tape would, instead of being positively charged, it would be negatively charged. The calculations overall would not change because this was a repelling force, and repelling force has to be the charges have to be the equal charge, so it can be 2 positives or 2 negatives. Why is it important to handle the charged objects as little as possible? What happens when charged tapes come into contact with your hands or other objects? Anytime charged objects are touching, the electrons are being transferred, so the charges, the exact electrical charge would change and vary depending on how it was handled.